In this video, we're going to take a look at the mole-mole relationship, and I want to show you a couple things. When we're talking about mole, we're not talking about this kind of mole. This kind of mole is not what we're talking about. And if you look up mole online, you actually have 4 famous kind of moles. And we are actually going to look at this first one. We're going to look at a mole unit, which is a unit of measurement used in chemistry. We're not going to look at the mole animal. We may eat some mole sauce, a guacamole sauce perhaps, and I hope there are no moles in terms of espionage in class, but maybe there are. So the idea of a mole-mole relationship is very simple. In a balanced reaction like this, and the beauty of the mole ratio is once we have the balanced reaction, we always will know the ratio of products to reactants. So for example, we could have 2 molecules of water, and we know due to the balanced reaction here that 2 molecules of water will give us 2 molecules of hydrogen and 1 molecule of oxygen. If we knew, say we had 4 molecules of water, then we would know that that would give 4 H2s and 2 O2s. All that will always remain the same is that ratio between moles. So 2 to 2 to 1 here is the same as 4 to 4 to 2 here. So if we had 40 waters, we would expect 40 hydrogens and 20 oxygen molecules. Here's a problem we could look at. We could say how many moles of O2 will be produced by the decomposition of 5.8 moles of water, and this is how we're going to use the mole ratio. So from earlier on we did dimensional analysis, so we remember that we're going to write our known, what we're starting with, which here is 5.8 moles of H2O. That's what I know I have, so I'm going to write moles of H2O. I can just abbreviate to moles H2O, and we need a conversion factor, and this is where the mole ratio comes into play. We can write the mole ratio as a fraction. So in this case, we're going to compare moles of H2O to moles of water. So we go up into the reaction, and we see that it's 2. We could use this one. That's fine too, but we'll use this one. 2 moles of water produce 1 mole of oxygen. So that becomes our mole ratio. Of course, our trash goes on the bottom, so 2 moles of H2O goes on the bottom, and then on top we put 1 mole of O2. Okay, these units cancel. That's our trash. And now we simply take 5.8 times 1, divide by 2, and we get our answer, which in this case, is 2.9 moles of O2. And that's how you use a mole ratio.